Good afternoon, and thank you for joining us today for the Igniting the Future news conference, where we'll be discussing a major announcement about the future of space launch. I'm Jessica Rye. I'm United Launch Alliance Director of External Communications. This news conference will include opening remarks from United Launch Alliance President and CEO Tori Bruno, as well as Blue Origin founder Jeff Bezos, and will be followed by a Q&A session. I will moderate the discussion in an effort to get through as many questions as possible in the short amount of time we have allotted. I'd also like to thank the Press Club for helping organize our event today. So now I'd like to unveil the model. I'd like to welcome ULA President and CEO Tori Bruno.
Thank you. And good afternoon. You know, before my remarks, I just have to say how honored I am to sit up here with, Jeff Bezos, one of our country's truly great innovators and entrepreneurs, a man who has really changed how things work. And I'll share with you, I could not live without Amazon Prime.
Thank you, Troy. I knew I liked him right away.
And now I'm proud to say also a colleague and a partner and a friend. So I'll share with you that I have been designing and building rockets all my life. And there is just really no thrill like, coming down, rolling through that countdown, seeing that big explosion of flame and smoke and watching that beautiful bird that you put so much work into sort of rise up into the sky on that fountain of pure fire. There is nothing like it. I did it again last night, and after 300 launches, it's the same on the 300th time as it is on the first time. It is really something. But I also have to say that it's very serious business. A rocket is a complex, powerful, and unforgiving machine, and it takes special people to be able to build them reliably and consistently every time. And I think also often about the responsibility entrusted in us when we put those payloads into space. Often, lives are on the line and depend upon our success. I think about that often. Everyone at ULA does as well. So I'm just going to take a moment to talk a little bit about ULA for those of you who are not as familiar with us. The United Launch Alliance is America's premier provider of access to space. We put up our country's most critical assets, our commercial customers' most valuable assets in investments in their business. We do this with absolute certainty. We are always on time. We have always been on budget, and we have an unparalleled record of mission success. As of last night, we are now at 88 consecutive launches, a perfect flight record. And we have touched your lives. Any of you who used your GPS to get here today, we helped you arrive. We've put up every single one of those satellites. People who were warned about a hurricane bearing down on their home, we made that possible. First responders getting where they need to be, that was ULA. And soldiers in the field who, got the information to, be safe and get their mission done, that was us too. All of that done with that level of certainty that I've talked about. But as I stand here and I look forward into the future, what are our customers going to need? It's clear to me that they need two things. They need that absolute certainty to continue, and they need their access to space to even be more affordable than it has been in the past. And so we've been off studying what the next generation of our Atlas and Delta launch vehicle family should look like. We've conducted thorough trades, and I am now here very excited and proud to tell you that we have selected Blue Origin and Jeff Bezos to be our partners going forward with their very innovative and creative rocket engine technology for our future family of lift. And I am so excited about this partnership because it's kind of the best of both worlds. We have, their innovative entrepreneurship together with ULA's, solid track record of success, certainty, and reliability. And it's really, sort of having your cake and eating it too. And as we make space even more affordable and more accessible to everyone, it's going to change the world. We are going to do for space in your lives, what the internet has done for the information age. That's our vision for the future. And I'm so very excited to be here, and I just want, I'll turn it over to Jeff.
Thank you. Thanks, Tori. This is incredibly exciting for Blue Origin. to be able to announce a partnership with a company like ULA that has launched, for the last 8 years, they've put a satellite into orbit almost once a month for the last 8 years. It's an unmatched record of success and just an incredible tribute to detail orientation and operational excellence. The BE4, this is what this is a model of. So the BE stands for Blue Engine. The Blue Engine 4 is Blue Origin's fourth engine. We're just about to flight test BE3, which is already finished with its development process. And I just want to take a moment to call out the Blue Origin team. This is an incredible team. I'm so proud of them. These are folks who are pioneers. They are innovators. They love space. They love rockets. They're passionate. I always tell people, if you're not passionate about space, go figure something else out to do, because this business is too hard if you're not passionate about it. And so we have an engineering team outside of Seattle, and we have our test and operations team in West Texas, and it's just an incredible group of people who have accomplished a lot in the last few years. The BE4 engine that we're talking about here is also going to power Blue Origin's orbital vehicle further in the future. It's a BE4 engine is a remarkable machine. It's 550,000 pounds of thrust. It has a very low recurring cost and low life cycle cost. Cost to space is a very important factor. So basically, cost and reliability are the two driving factors. The BE4 uses commercially available fuel. It's liquefied natural gas. It's reusable, and it's built and tested and designed and engineered 100% in the United States. There are two things that I think are really important to note about this engine. One is that the BE4 development process is already 3 years underway. There is no way to rush a rocket development process. You can't cut corners. It needs to be methodical and deliberate. And so the reason that we can accelerate the time frame of the BE4 is because we're already 3 years in to the process. There's a second thing which is very unusual about probably the rarest of thing that you can ever find in a rocket engine, and that is that the BE4 rocket engine is fully funded. You know, I think it's pretty clear it's time for a 21st century booster engine. The great engines of the past were truly remarkable machines in their own right. The engines that you remember that were built in the 50s, 60s, and 70s, remarkable pieces of hardware. But we have tools and capabilities, software simulations, computational horsepower that the builders of those great engines could have only dreamed about. We can build an engine today that is a 21st century engine that has great reliability, low cost of operations, and high performance. And we're super excited about that, and we couldn't be more excited to have a partner like ULA. Thank you.
We will now take a few questions. Please state your name and affiliation and wait for a microphone to come to you. And I will, we'll start here in the front. Lauren, with Seth.
Thank you. Seth Borenstein, Associated Press. For Mr. Bezos, since you don't often talk to the press about Blue Origin, I'm going to veer off a bit into your crewed attempts here, CREWED. Just wanted to make sure.
Highly sophisticated crewed attempts.
And given yesterday's announcement by NASA, picking SpaceX and Boeing, are you still going to pursue a crew vehicle on your own Blue Origin privately? Will you, if so, are you going to attempt to have NASA as a customer regardless of the CCTV program? And in terms of reliability, you've been notoriously private about successes and failures. how many engine firings have you had, and how many of them have succeeded?
Let's see. God, I'm terrible at multi-part questions. I'll probably forget some of the parts. You can remind me. Yes, we're still continuing to build our own orbital vehicle, and it will have our own space vehicle. And that the timeline for that is late this decade. So we continue on that path. Our motto is gradatum ferociter, which means step by step ferociously, and we continue on that path. What was your other question?
How many, in terms of
The BE3, so the BE3 engine has, you guys might have to help me in the back, but it has over 10,000 seconds of test time and hundreds of starts on it. There have been failures, but there have been remarkably few failures. That's one of the advantages that we have when we're developing rocket engines today that didn't exist really even 10 years ago. You can today do combusting CFD, computational fluid dynamics. We have the computational horsepower and we have the validated codes to be able to do that. And I would just hasten to add that the reason that we have those codes is because we stand on the shoulders of all of those people in the past who have built rockets the hard way. It's still hard, but it's getting so that you can get into test faster, and you can do many tests per week. In fact, in many cases, we're doing multiple tests per day.
Do you have a proportion, though, of failures?
I don't have a proportion of failure, but it's going to be, I think if I just look at it, it's got to be less than 2% failures.
All right, we're going to go to the back with Andrea.
Andrea Ashalal with Reuters. I just wanted to ask you both actually separate questions. So, Tori, if you could walk us through the timeline for when you can integrate this engine and what sort of cost savings you anticipate to be able to transfer then to your customers at the Air Force. And Mr. Bezos, just a question about the progress and the work that you've already done. Can you just give us a little bit more detail about what you've done and when you anticipate that the engine will be ready and what kind of testing will be needed then?
Sure. I should also add to my prior question that 2% is during the development program. We would never tolerate 2% failure in a production engine.
Shall I go first?
Please.
Sure. Well, great question. Glad you asked it because it has a lot to do with why Blue Origin is just the right partner for us at this moment in time. To develop a liquid rocket engine takes a solid 7 years, sometimes longer. And Blue is already several years into that cycle. And so by partnering with them, we have the opportunity to really cut that cycle in half, which means that, say, about 4 years from now, we would be in a position to begin flying rockets with this engine technology. And in terms of the actual specific cost savings, I think it's premature for me to quote a specific number, but it's clear to us that they are substantial, and we are going to pass those on to our customers. That's what this is all about.
In terms of some specifics, some of what takes a long time in developing a rocket engine is the infrastructure work. So we have built in West Texas an engine test stand which is designed to support thrusts of over 1 million pounds. And that took us 3 years to do. It just got commissioned in recent months. So that's an example of a 3-year kind of project. Large engine test facilities cannot be done quickly. There's just a lot of pouring of concrete and waiting for it to dry. They're big. And that is, so that's an example. But there have also been tests of subscale injectors, injector element tests, and we're very close to doing all-in power pack testing on the BE4 engine. So all of what I just said is related to the BE4. There are, lots of things have gone on with the BE3 engine. That one is close to being flight ready.
So we're going to go to Warren and then Joel.
Yeah, I've got a couple of questions. First for Tori. Do you envision the BE4 as a replacement for the Atlas V or Delta IV vehicle, or is it a new engine for a new rocket altogether? And I also have some questions about the financing of this program. I'm wondering if, for example, Mr. Bezos, are you taking an investment in ULA? Or alternatively, is ULA paying Blue Origin to develop this engine?
Sure, let me start first with the technical part of that. So, the BE4 is not a one-for-one replacement for the RD-180, which is a kerosene-burning engine. But what we intend to do is to use a pair of these on our baseline Atlas vehicle that would provide actually higher performance, higher thrust level together than what we have now. RD-180 is a great engine. It's a real workhorse. It's reliable. It's high performance. But this is an opportunity to really jump, as Jeff said, into the 21st century with modern technology so that we can achieve more performance at a lower cost. Now, we intend to stack on top of that the common components that we have developed in the upper stages that we already have in our Atlas and Delta family. So it's really inserting an engine, modifications to the rocket to accommodate that, and then reaping the benefit of that higher performance and more, greater agility in terms of the propulsion system.
Do you envision continuing to operate two vehicles?
Well, as I said a few moments ago, we're 4 years away from our first flight, and then we have to pass through a certification process that is appropriate to whatever degree of change the vehicle has experienced. So there are a number of years when the existing Atlas and Delta with the existing engines would be flying before the BE4 is ready, and then there would be an overlap where it's feathered into the future.
But I mean, going forward, once a vehicle is developed with this new engine, does ULA neck down to one vehicle that's powered by the BE4?
So we are currently in the middle of our studies on exactly what the vehicle configuration will be that uses this new propulsion technology. And I would be thrilled to be back here with all of you again at the end of the year to tell you about what those studies reveal.
And then in answer to your second question, there's no equity changing hands. There's no equity investments going on as a part of this. ULA is making a very significant dollar amount investment in the engine development, which we're not disclosing what that investment level is, and Blue Origin is committing to finish the engine.
All right, Joel?
Okay.
Joel Achenbach with the Washington Post. Just a
Excellent publication.
Thank you. I agree. Yes, thank you. And I have a question about that, sort of, actually. But first, I'm having an issue with the scale of this. So first of all,
The real one is about 12 feet tall.
right, okay. So that's just a little bit of, like, this is Spinal Tap, it's not quite as big
Yeah,
as it.
bigger.
So how much does one of those things cost? I know you said you didn't want to talk about the dollars involved, but we need to tell our readers, how big a deal is this? I mean, I assume that costs more than a couple $1,000s. I mean, can you give us some sense of the scale of this deal? Is this going to go on for years? I mean, ULA does a lot of launches. Does this mean that it will become the only engine used in these rockets? I mean, what's the scale here?
Well, first off, this is a first-stage engine that we're talking about, and our rockets are multi-stage. We're not currently talking about changing the upper stages. So we still have the RL-10 that we use in the upper stages of both vehicles, and on the Delta, we have the RS-68, which is derived from the world's, largest liquid engine with, its heritage back into the Saturn. So we want to understand that what this engine is really about. And in terms of the future, will this be only one engine for one type of vehicle? As I said a moment ago, trades are still underway, and I look forward to telling you all about the configuration of that rocket family later in the year.
And our goal is to make the engine so operable, so low cost, and so reliable that ULA would be crazy to use anything else.
I know other questions are waiting, but Jeff, you're involved with so many things. Now, it's been said that you spend a day a week at Blue Origin.
Yeah.
Obviously, you're passionate about space flight,
Yes.
involved with content creation in our newspaper. How do you decide where to spend your days? How do you manage your time?
Well, Amazon is my day job, and I love Amazon. I love I took my family on vacation. We were gone for a week with my extended family. I got back. I loved the vacation. It was great food, and we played in the water, and everything was good. I ran back into the office when I got home. So I'm very, very lucky. I get to live and work in the future. And so that is it's fantastic, and that's where I spend the vast majority of my time. I'm also very lucky because I don't have any hobbies like golf, so it frees up time. And so you don't choose your passions choose you. And for me, space is something that I have been in love with for since I was 5 years old. And I watched Neil Armstrong step onto the surface of the moon, and I guess it imprinted me. And but for whatever reason, I've always been interested in space and space vehicles. I think it's important. I think it's important that the United States have an American-made booster engine. And so I'm very excited about this. I'm very passionate about it.
So we're going to go to Frank, Keith, and then we'll come to the front row.
Thank you. I'm Frank Boring with Aviation Week. This announcement is coming in the context of a discussion here in Washington about replacing the RD-180 with something. Are you in contact with the Air Force about doing that? And then there are other people doing that, so I'd like a little bit more information about the engine itself, starting with motorhead kind of stuff like the cycle, the specific impulse. You also mentioned that it's reusable. How are you going to get it back? And again, the question about whether you're just going to use the one engine or you're going to stay with both. Is this a one-size-fits-all down the road?
Let me start with the easy question.
Yeah, sure.
So to answer the easy part, we have been in contact with all of our stakeholders to let them know what we're up to, and the feedback has just been overwhelmingly positive. Everyone is so very excited about this partnership and this opportunity, that arises from this technology. Okay, hard part for you.
The engine uses an oxygen-enriched stage combustion cycle. We chose that cycle because of its high performance. We evaluated all the usual suspects in terms of operating cycles. We looked at gas generator, we looked at tap-off, and we chose ox-rich stage combustion as the right cycle for this engine. I think it's been a very good choice. It's 550,000 pounds of thrust. It uses liquefied natural gas as a fuel, liquid oxygen as an oxidizer. It is, as you can see from the model, it is a single turbopump, one shaft. So we're very excited. It's as simple as it can be while still being high performing and highly reliable.
I got to say, I just love this guy. I am used to being the only rocket scientist at the front of the room. Well done.
Keith?
Keith Cowling, NASAWatch.com. For Mr. Bruno, do you intend to use this engine or a variant thereof to launch human crews, such as the CST-100? And was there any mention of this engine in the proposal to NASA for the commercial crew contract?
Yeah, so I'll start with the second part because that leads to the first. So the answer is no. So we proposed that activity based on the family that we have in hand now. And the first flight for commercial crew is in, as I said, 2017, which is ahead of the availability for this new engine. Now, as I said earlier, as we, execute through that program over time, if our customer would like us to make a change, any change, including this one, we're here to support.
Right. Front here, please. I'll see you next.
I'm Kyung Sung with the Seattle Times. Would it be more economical in the long run for the U.S. to just settle on a single space capsule, space vehicle?
Well, let me take that one. So, it really takes, a spectrum of vehicles in order to cover the entire mission space that our country requires. And I think your question was specifically about the government, so I'll leave the commercial market aside for a moment. But, the payloads that we put up vary enormously in their size and in their velocity. So, for example, when we put a satellite up, a GPS satellite, into low Earth orbit, that's a certain velocity. I won't torture you with the numbers, but that's a certain speed required to achieve that. When we put NASA's New Horizons Pluto probe out, that is so much faster and of a very different configuration. So you really can't do that spread of missions with a single rocket. So you have to have a family of vehicles with different capabilities. Now, we are very sensitive to exactly the notion that, you're really driving at, which is, what's the most affordable way to do that? And doesn't having something that's common, speak to that affordability? And you're absolutely right, it does. And so what we've been doing is taking that family of vehicles, and the reason we call it a family is because they share many of the same components across. So, a single avionics computer, a single set of, ordnance and separation hardware, so that you really have a basic, set of equipment that you build the rocket out of. Even within the family, we have what we call a common core, so the center rocket, the center first stage booster will be the same, and then we add pieces to it as greater capability is required, and then remove them as it is not. That's the most affordable way to cover the whole wide spectrum of mission.
So we're going to have just a couple more questions. So we're going to go right back here to the gentleman in the blue and then over to Aaron.
Hi, Caleb Henry via satellite. List of questions. I know you mentioned you hate those. You mentioned that the engine will be involved in a launch vehicle. Just wanted to confirm that that's New Shepard.
Yes, the New Shepard is powered by the BE3 engine, not the BE4 engine.
Okay.
So the BE3 engine, the one that's about to go into flight test, is the one on New Shepard.
Okay. And then two-part question. Is this partnership with ULA, will it extend to your work with Boeing on the XS-1? And then Congress has been debating, how much funding to allocate for a domestic engine. Will Congress still be participating in funding this engine?
I'll take the first one. Those are really two completely separate things. So they're not. This announcement really isn't related to yesterday's announcement. And of course, we're a part of Boeing's team, and we stand ready to help them in any way that they want us to.
He was asking about the DARPA program, not the.
Oh, I thought you were asking about yesterday's program.
Yeah, I meant DARPA.
No, I'm sorry. The DARPA program is also, first of all, it's very early. It's a relatively small-scale program right now. No real hardware has been funded. But the engine that we would propose would be the BE3.
All right, excuse me, we need to go to one last question for Aaron.
Hi guys, Aaron Meadow with Defense News, over behind tall people. Just wondering, the ULA, I like that one. ULA announced in, I think it was May or June, that it was going to be funding a series of small research contracts to decide how to move forward with this. Did this come out of this partnership come out of those contracts? And if so, were there other competitors whose contracts you found, or suggestions you found, weren't as powerful or as worthy to move forward with?
Yeah, so the first part is, yes, absolutely. Those studies and those contracts that enabled the studies resulted in the trades that allowed us to make this selection. And we cast a pretty wide net. We went to just about everybody in the industry. So I think we got a very good understanding. And we selected Blue for a couple of reasons. First, they're way ahead in terms of this 3 years of great development. Also, they have this, really innovative technology that we talked about that's going to allow us to modernize, increase our performance, and lower our recurring cost. And, as I said before, of course, this is rocketry. I have contingency plans, but this is my partner, and I am expecting, Jeff to succeed.
All right, with that, we would like to conclude our news conference for today. We are going to allow for some photos up here, so I'll move the mics and we can take some photos. Thank you to Tori and Jeff, and thank you for joining us today.
Thank you, guys.